Today we are learning to apply vector terminology and concepts to find sides of a triangle and magnitude. We will be successful when we can precisely solve 2D vector problems of triangles and magnitude. Okay. So for the first terminology that we'll need to know today is what is a vector. A vector has both direction and magnitude. It looks like a little arrow, like that, right there. Our second term is magnitude, and that is how long it is or the distance a vector covers. Some really useful forms of vectors is unit vector form, which is a way of writing a vector in terms of I, j, and k. So I, j, and k all represent different components that we know otherwise as different letters, such as I equals x, j equals y, and k is z. Okay. And component form. So this is the way that you're most commonly going to see vectors, and it is a way of writing it vertical. That involves I being on top, j being in the middle, and k being at the bottom. So example 1, we have triangle LUZ has point L in component form 2, 12. It has point U in component form, which is 3, 9. It has point Z in component form, that's 1, 5. So it's asking you to find the vectors UZ and LZ. So first of all, it's going to be really helpful if we actually write where they are. That'll give you an idea of what to do next. Okay. Then to find vectors UZ and LZ. So LZ is this vector right here. So it starts at L and ends at Z. And those points are 2, 12, and 1, 5. So these are the 2 points that vector LZ is composed of. Now, to find the vector LZ, we're going to need to subtract the end point from the starting point. So we're going to get in component form 1, 5 minus in component form 2, 12. So that's going to give us 1 minus 2 is negative 1, and 5 minus 12 is negative 7. So that's vector LZ. Now to find vector UZ, we're going to do the exact same thing, but this time we're going to use the points for U and Z. Okay, so we want to get the end point. So it starts at U and ends at Z, so we're going to grab the points from UZ, which is in component form 1, 5, and we're going to grab the points from U. We're going to grab the points of U, which is 3, 9, in component form, of course. So we have 3 and 9. So then 1 minus 3, that's going to be negative 2. And then 5 minus 9 is going to be negative 4. So then we have that UZ. So vector UZ is negative 2, negative 4. And we found that vector LZ was... Okay, yeah. And the result for LZ that we got was negative 1 and negative 7. Yeah, so that's how you find vectors from a triangle when you know the points. Okay, so now we're going to keep going with example 2. And for example 2, we're going to find the magnitudes of vectors LZ and UZ. So on our previous example, we figured out that that vector UZ was in component form -2, -4, and that vector LZ in component form was -1, -7. So now we want to find their magnitudes. So the equation for finding the magnitude of a vector is in your IB formula booklet, and it is as follows. So the magnitude of a vector equals the square root of v1 squared plus v2 squared plus v3 squared. Okay, so v1, v2, and v3 are just the parts of a vector. So, for example, there'll be I, J, and K. Okay? So for these purposes, let's start with vector UZ. So vector UZ only has two. It only has I and J. So we're going to eliminate this one. So I will put in I for V1, which is -2 squared. And then we'll put in -4 for J, or V2, which is -4 squared. Okay, and since a negative times a negative is always a positive, we are going to have the square root of 4 and the square root is 16. Okay, so then 4 plus 16, that's okay. So then the square root of 4 plus 16, that is 20. So then the square root of 20 would be the magnitude of vector UZ. So the magnitude of vector UZ would be the square root of 20. Okay, and now for the magnitude of vector LZ, we're going to use the same equation. Okay, so then for I, or V1, we're going to replace, we're going to put in -1, so -1 squared, and for V2, we're going to put in -7, so -7 squared. Okay, so then 1 squared is 1, and -7 squared is 49. Okay, so then we have the square root of 50. So the square root of 50 is of vector LZ. Okay, and now it's time for you to apply what you have learned today. So I have one problem right here with a quadrilateral, and the problem is find sides CE and CU. Okay, and then we have our second problem right here, which is find the magnitude of vectors CE and CU. Okay, okay, I hope you enjoyed my video today and you learned, and give me a good review and thumbs up. Oh, how do you do? Thanks. Okay, now for the answers. Okay.